Alrighty, our second approximation method, Simpsons Rule. Simpsons Rule is derived by a guy named Simpson, funnily enough. It's also an approximation method for finding area under the curve. If you haven't seen the trapezoidal rule one, go back and have a look at that. Simpsons Rule is a different method for finding an approximation. It's the last rule for finding an approximation we're going to do. Then we'll look at exact areas under the curve in a bit. But Simpsons Rule, it's not super bad. It can be a little bit tedious to remember, but we'll try and pull in elements of the formula sheet, their version of the rule, to make things a little bit nicer. So, trapezoidal rule, well, curves, approximations. So, that's not very straight. So if I draw myself a line or a curve, let's draw it between here and say here, and this can be my curve in here. Simpsons rule, what it's going to do, it's going to require that I have two houses, if you like. So we talked about trapeziums as different intervals or subintervals. Here you've got 1, 2 houses, 2 heights to work with Simpsons rule. Now the trapezoidal rule, it said you drew trapeziums. You've got one trapezium here, then you got a second trapezium over here, and you found the area of those trapeziums. Simpsons rule works a little bit different to that. What Simpsons rule does, it's going to assume there is some parabolic shape between these two. So if I try and draw a parabola in here, it's going to look really messy, I know. There's some parabolic arc between those two there. It's not straight. The diagram's not very good. But there is some parabola in there. It takes that then and applies a rule to it. The rule, it says, for Simpsons rule, it says h on 3, and then it says f of a. Well, let's call them a, b, and c again. Make life a little bit nicer for ourselves. It says f of a. So this here, of course, is a, f of a. And we've got f of c here. So c, f of c. And this is b, f of b. It says f of a plus 4f of b plus f of c. Okay, so what's different in here? H has changed. Well, H hasn't changed. H is still in here. H is still the width here. But H is over 3 now. Okay, something to watch out for. And it's 4 times the middle. H on 3, first and last, 4 times the middle for Simpsons rule. Looking at generalizing this, because, I mean, one case is good, but the more cases we can do, the merrier. So pulling more intervals into it, and of course, the more intervals we put in, the more accurate our approximation is going to be. So we'll draw a line through here. We'll have this here. That's not in the middle. So what we have here, we're going to have 2 applications of Simpsons rule. We're going to have an application for our first half here. Going to have another application for our second half in here. Just labeling my points A, B, C, D, and E. I get f of A, it's my height, f of B, f of C, f of D, f of E. Combining my approximations here, I get A, the area, is approximately equal to, because it's an approximation method again, H is this distance in here, of one house. How big is a house? H on 3. It's going to be then f of a plus 4 f of b plus f of c. Then for my green approximation, I get h on 3 again. I then get f of c is the first value here, plus 4 f of d plus f of e. And again, I will combine these like I did on my trapezoidal rule. So f of c does occur twice. F of c here and here. So I get A is approximately equal to h on 3. I get there's f of A, just one f of A. There's 4 f of B's. There's 2 f of C's. There's 4 f of D's. And there's an f of E. Okay, so ugly. I get that it's ugly. What you want to note is 4 of these and 4 of these, and then 2 in the middle. It's a pretty common process for students to come along when they get their approximation, the Simpsons Rule graph. They might get a table of values as well. I'll just show you by table of values. So they might have on the table of values, they'll have x and f of x. So they'll have A, B, C, D, E. Then whatever f of A is, f of B, f of C, f of D, f of E. And the pattern does continue. So we come along, our first one we give 1 to, and the last one there's one of those as well. So there's one of those and one of those. See here, one of these and one of these. 1 and 1. Then we start our pattern 4, 2, 4, 2, 4, 2, 4, 2, 4, 2. So 4, 2, and 4. So there's 1 f of A, 4 f of B's, 2 f of C's, 4 f of D's, 1 f of E. 1 f of A, 4 f of B's, 2 f of C's, 4 f of D's, 1 f of E. All right, a little bit messy. We'll do I'll show you the rule with 3 approximations, and then I'll save the rest just for, I'll do some examples in a video with some questions on it. But coming through, if I do have a bigger Simpsons Rule question, and say this is my curve here now, so I'm going to do here 4 applications of Simpsons Rule. So my points A, B, C, D, E, F, G, H. Okay. Oh, I is next. Sheesh. H, I. So f of A is the height, f of B is the height, f of C is the height, f of D is the height, f of E is the height, F is the height, f of G, f of H, f of I. You should always get them in pairs of 2. So just checking, we get pairs of 2 here. We've got 1 pair of 2 for our first approximation in here. We've got another pair of 2 for our second application of Simpsons Rule, our third application of Simpsons Rule in here, and our fourth application of Simpsons Rule in here. They should all be equally distant apart, so each of these should be the same. I know it doesn't look like it necessarily in my diagram now, but that's because I can't draw, not because if anything weird with the question. That should always be H, and H will always be the same the whole way through. So obviously doing 4 approximations, 1, 2, 3, 4, drawing it up 1, 2, 3, and 4 is going to be a little bit of a track. So what we can do, we can go through labeling as we did in our last example. We want 1 of the first, 1 of the last, and then we go 4, 2, 4, 2, 4, 2, and 4. The rule on the formula sheet is it's B minus A on 6. You can kind of ignore that. It's the H on 3 part, but then it says f of A plus 4 f of B plus, no it doesn't, it says 4, excuse me, just go back a little bit, plus 4 f of B minus A on 2, lovely, plus f of B. So that's for one approximation there. The approximation, if you consider this one here, you got 1, 4, the middle. This is basically just saying the middle. and there's 4 of those. We've got 4 of those here. There's one of these, but f of b, or f of c in our case, this middle one here, gets included in our green one, and again in our pink one here. So like you saw a bit ago, it's in the green, it's in the pink, you can combine them, so we will combine them here. If you are confused, the reason I wrote this here is if you are confused, what comes first here, look at your formula sheet, borrow that 4 there. One application, 4 in the middle, second application, 4 in the middle, third application, 4 in the middle, fourth application, 4 in the middle. The 2 is in the green and red. The 2 here, it's in the pink, so the red and the green, and the 2 here, it's in the yellow and the blue as well. So drawing up my Simpsons rule for this one here, of course, don't use A, B, C, D, and E. You must use the function values. You must get the actual heights in there. So my area here is approximately equal to, here we go, h on 3, f of a, my first, plus f of I, my last. You can write it out 4f of b, 2f of c, 4f of d, etc. Or you can factorize, you can say 4. My 4's, I've got f of b. I've also got 4 of f of d. I've got 4 f of f's. And I've got 4 f of h. And I've got 2 f of c's. I've got 2 f of e's. I've got 2 f of g as well. So that will get me my area, my approximation. Obviously, it's quite tedious. Here, like I said, I've pulled the 4's out. The 4's f of b, f of d, f of f, f of h, and then the 2's, I've got f of c, f of e, f of g as well. Okay. Like I said, you could write it the other way, so you could come back and say a is approximately equal to h on 3, f of a. So f of a is there once. There's 4 f of b. There's 2 f of c. There's 4 f of d. There's 2 f of e. There's 4 f of f's. There's 2 f of g's. There's 4 f of h. And there's 1 f of I. Okay, I prefer this method here, just because it saves me getting confused drawing this all out. And what I would do, I would go and find my function values before I start looking at my formula here. So when I do some examples, you will see me do that. But that's the theory. I would recommend copying a diagram like this or something similar down, making sure you get that pattern there. So the pattern, 1 either end, 4, 2, 4, 2, 4, 2, 4, 2. Then make sure 4's, all the 4's go in a 4 bracket, 2, all the 2's go in a 2's bracket, the first and last at the front by themselves. Definitely watch some examples on this. I know it's tedious, I know it's kind of boring, but it will help us later on. It's a good idea. It's good to kind of help us get our head around integration, which we'll have a pretty firm look at in a minute. Thanks for watching.